Thank you, Lars, for the nice words, and I'm really happy to be here again. So last year, it was after the Corona crisis, I would say, where we meet us all again, and it's really like a family. I remember the first days we had Ethernet congresses, and we always ask, who knows something about Ethernet? There was some there, some not, and now we see it's really a family. There's a long journey, 15 years, it's a long time. We all see we're getting old, artificial systems getting not old, we're getting old. We make a lot of mistakes, we learn of our mistakes. We will see if the artificial system will be that successful as we were in the past. So again, why it's important, I would say, to know where we come from. It's always good to know where we come from, because maybe then we know a little bit about the future journey and to see where we are. So here's the system to switch. So what I would like to show you today is where we come from, where we are today, where we may be going to, and in a summary I would like to have a little bit outlook and maybe even some warnings, what we could do maybe. Yeah. So where do we come from? As you know, I think there's not a mistake behind, or not the magic behind. In 2004, it's really a long time ago. There was still a problem that the software update of a car is critical. That was not changing in these days, because a lot of companies are fighting with the software update of the software-driven, software-defined vehicles anyway. And it will be more and more critical. In 2004, we had the situation when you do not like to work over CD-ROMs in the past, or over USB sticks in the past, and you want to make a software update of a car. With a diagnostic interface, there was only CAN there. And there was the upcoming MOST 25 megabit, as a solution, but it was too slow for the service update. Software update with a car in the software stages of 2008, it's really not a lot of software, but in that takes about 16 to 24 hours. So it was much too slow. So we were looking for pragmatic, simple solutions, and we found one. We're using standard Ethernet, 100 base TX, with a clever combination with an activation line to switch on and switch off this PHY, and we could use standard Ethernet for the programming update, software update. It was a big success, and we set the basics with all the upcoming things like you have today. DYP, I think everybody knows what this means, and it was the mother of DYP. But this was only Ethernet in automotive. Now we talk about the transition from Ethernet in automotive to Automotive Ethernet. So the vision we had 15 years ago is to find a communication technology, a communication platform, where we have convergence. Convergence of bringing the different data together, video, audio, control, data. We need a future-proven system where we introduce new speed grades, new solutions without throwing everything away. In the past, when we go from LIN to CAN to FlexRay, wherever we did, we always throw everything away and go with a new physical layer, we're starting at zero. It's a big problem. And with Ethernet, we were pretty sure this is a solution that we get rid of these issues. Then we need a single scalable network from a tiny car to a big car. We need a forward compatibility, I just said about it. New speed grade shit coming in, new protocols coming in, without killing the rest, was always there. And of course, higher bandwidth will be always needed. And it is modern, whatever modern means. Modern always needs mistakes as well. But modern means we have the situation that we can introduce solutions like service-oriented architectures and so on. But the question was always where to start, okay? And where to start, simply said, the PHY first. Wanted the Automotive Ethernet PHY. So nobody would say, what's special? Yeah? And I want to see this picture here. This picture, you see one of the first prototypes we had for Ethernet. There was a big discussion in the early days, is 100 base TX with the four line system, so two pairs of a system, the right one with doing some optimizations, or is one approach that one vendor had, the two-wire approach called Broadreach, now you can expect what kind of vendor it is this the right solution? We have a big discussion. Yeah? And you see one big issue, one big problem, and you see it directly in the picture behind. You see this big thing here. This big thing is a transformer. And after this time, nobody was thinking about a common mode choke in the car. A common mode choke as tiny as it can? No, this was the old solutions, big transformers. And we bring it down, so the down picture is in the same scale. Now you see what we have in our car. Why this big monster here is a problem? It was handmade. Handmade will not work in any automotive requirements. And again, the automotive requirements are different from, let's say, some or the other consumer or communication technologies. There are some issues like a fast startup, connectors must be robust, I think it's clear. The total cost of ownership has to be as minimum, and the quality is essential. Yeah? So we're replacing a transformer with a common mode choke, but this is not done on a plan. That has to be done step by step, approach by approach. And EMC and ESD requirements, of course, are critical. Yeah? And if we will not overcome this issue, we will not talk today about Ethernet in a car. To be absolutely clear, this was one of the key successes we had. And then, very funny story with Ethernet. I think that's really very interesting. Maybe I don't know if everybody knows it. You know, the last years always there are new crises. If it's the semiconductor crisis, if it's the Corona stuff, and in 2007, 2008 there was a financial crisis. That has the impact that we were not able to work on any new things because money was really a critical part. So Ethernet has to start in a cost down program. So how does this fit? Bringing new technology in and save money first, but we got it. So the message is we introduce a new technology, and in the same time we introduce this new technology, we save money. And this was the time to start. And additional to that, we use this solution for a camera surround view system. We call it Detour, because original Ethernet was not planned only for the video system. It could be a possible solution using surround view cameras. Still, solutions are left for review cameras. Surround view cameras as maybe will go in the LVDS or CRS solutions as well. But Ethernet was very good in this time, and we save a lot of money. You see some pictures there. It's really like the line downstairs where the transformation is done. And this is the first prototype of an Ethernet camera that is then being used for serious production. So now back on track. The question was, okay, now we have a good idea. Everything is working. We have a cost down, functionality, everything there. But then we recognized, oh God, without the ecosystem, we're lost. And who will build this ecosystem? If nothing is there, somebody's to do it. And that's why we have to create an ecosystem from a software stack, from a lot of other features that is needed. So we have the discussion starting the service orientation with some IP. If you know what's happening inside the car, you know that you have to have a network management, startup, shutdown management, audio transport via AVB. And of course, we've driven a lot of standardization. The Open Alliance Autos are ISO, and you just see, I forget IEEE. Of course, IEEE is a very important standard that has to be built up. Yeah? On the right side, you see some examples where we look to Ethernet data on Wireshark, on CAN data, and so on and so on. But that's not all. That's not all. To be really ready for serious production, it is a really high quality required. And that's a difference from automotive. You have millions of startup, millions of car around. You have to do interoperability tests with a lot of files. You have to do EMC test houses. You have to build up EMC test houses. And again, uncountable hours of testing and integration. So this was a hard work for the whole industry as well. And I'm really proud, based on the success, you see that a lot of people are coming up and we have a lot of things going ahead. So from the timeline perspective, maybe you have a little better feeling if you see it on the timeline. It's stopping in 2016. I stopped now with the Gigabit standard as it is today, 1000 base T1. This is, let's say, where we come from. When you look to the slides here, again, everything started with diagnostics. Then file development has to be done, some IP set up. Then very, very important for us in the early stage, because we do not believe in theory. We need a second source, minimum a second source for this file. We build it up together with a good partnership, even with the one vendor who will build the first file was helping very strong that we have an ecosystem up and running. Then we were talking about the AVB audio stuff. Interoperability test is coming up. Some IP was introduced, and so on and so on. Yeah? And then in 2016, after 2016, we see a lot of other OEMs. When I was talking I was working 18 years at BMW, as maybe one of you know. So then a lot of other OEMs were following this direction, and it starts through. So I would say it was a great start, a great success. We didn't start Ethernet with a task force. It was everything up and running, and I'm still proud that this start was really good. Yeah. Then where we are today. And that's something where I said now I'm starting to be a little bit more critical, because at 100 megabit everything was looking pretty smooth and everything up and running, and then Gigabit, 1000 megabit was following. And we see that there was a lot of competition with the 5 vendors. That's good. By the way, competition is always good. But what we see is that some of the interoperabilities cannot even sometimes catch up with the situation. Yeah? And this was a critical time, because there was a situation where the Gigabit system was not really interoperable with all the different vendors. That's a presentation that we did at Technica Engineering. We did a lot of tests and show what we can do together with the industry. The good news is we overcome this critical path. Now everything is green and everything is interoperable again. But my warning is, be careful with the next speed grades. We should not make this mistake again, because it's very dangerous for this ecosystem. So where we are today, you know that security is in all the discussions getting more and more critical. And for security, we need solutions that are a little bit more simpler, and that we can use so that the security issues do not block us in the next generations of setup. So network security is getting difficult, the speed grades are getting high, and you cannot do a lot of security by software, you need hardware support. And you have to be as flexible as possible, so unicast should be even possible, not only unicast communication. So that's why we said we use a standard that's already there, it's called MACsec, and now we drive the issues of Automotive MACsec. Why this is important? This is important because the PHY and features in the PHY is needed for that. So that means you need a front loading in the industry to go this ahead. And the first proof of concept was done in 2018, now again years ago. But it's very important to have this front loading so that the semiconductor colleagues can really do the right designs. For that, in automotive, you need a startup. Yeah? If you use standard MACsec, you will have a second startup till the key exchange mechanisms are starting up. Yeah? We bring it up and running, and we are now about 10, 30 milliseconds dimension how we can start up. Yeah? And that's very important, because this is the front loading we need, and that's where we are today. Front loading already done, next thing can come up. So now we are going. Where we're going is that everybody is talking about the software-defined vehicle. And there are new, let's say, architecture solutions that are coming up. Especially the zonal architecture is an interesting part, because you end up with the situation that the harness of a car is getting more and more critical, and a lot of, let's say, OEMs are looking to a zonal architecture design, including the SDV platforms. And the SDV platforms normally are high integration platforms, as you see in the picture, high integration platforms that get data out of the system, and that means the data-driven part is important. So it's really important that the integration platforms, the high compute platforms, get all the data. Yeah? And you can make it on different ways. If you do it right, whatever right means, you have the chance that you get all the data, even upstream data that were, let's say, has the source on a LIN or a CAN bus, a very low speed system, up to the high integration platforms. And this is very, very important, because this is an indication if the scalability of the system is working, and it's okay. So the trends that we see, of course, causes now a lot of things that is coming up, because the discussion is integration platforms getting higher and higher. Do we still need Ethernet networks outside, or is anything only a big computer and a lot of cables to this big computer? We all know that's nonsense. There will be something in the middle. There will be an external network, Ethernet driven, clear, and there will be integration platforms. They need special IPC solutions with PCI Express, multi-gigabit Ethernet, whatever they are. We have to talk about switches with multi-gigabit support, of course. And we should not forget, there will be a situation where we come to the point where we have to mix speed grades. So there will be a 100 megabit link, and the 100 megabit will work with a gigabit link, or down to a 10 megabit link. So that's why you will see The mixing of speed grades will be next challenge of the whole network stuff. Yeah? And again, multi-gigabit is good, but on the other side, we know it's power hungry. So that means we have to look to the power consumption as well and not only to the things. So where we are today, the message is we have to look more to the data inside the network. We have to look to write communication sequences. So now we have to talk about where we are going, okay? And we see there are now a lot of, let's say, innovations on the way. New 5 generations are there, and I'm really surprised. If you look about 100 megabit, and we're so happy that we have 100 megabit over an unshielded twisted pair of cable, and now we're talking about multi-gigabit. Yeah? It's really tremendous. It's really, really cool. To that, there is now a lot of alternatives available where we said, okay, we have to look to the power dissipation at all. So you look to alternatives where you said, okay, is it really important to have this asymmetric solutions? Maybe better because you can save energy. This is a fight and a discussion that is going on, and it's very, very good because this is innovation, having discussions, finding the right solutions. We see that now different solutions like coaxial is coming up, optical discussions again. The good news is the ecosystem is still there. We still have the system that is today, and now we can do additional adaptations to the system. In the past, if we would not have Ethernet, we would talk about throwing everything away and starting at zero. The good news is we have Ethernet. So the message is these innovations are on the way, and these innovations does not kill our today's design. So even if we still work with 100 megabit, maybe some of the people working with 10 megabit, in parallel, multi-gigabit designs up and running, and everything is coexisting, and that's the cool story behind. Yeah? So we see the vision is coming up. And then there is, let's say, solutions like TSN with many tools. We don't see everywhere a clear use case today because a lot of these solutions are relatively complex, and we have to be careful that we do not overcomplex the system. But the technology is there, and I would say from communication perspectives, the limitations are really not that high anymore. So there's a lot of solutions upcoming. Yeah. The question is, of course, and that's a little bit the risk, if the technology is improving and a lot of IEEE standards are coming up and standardization is going ahead, are we sure that ecosystem can follow? Are we sure what we're doing here? That's a little bit my warning, I would say. Please be careful, because if you're doing, let's say, I call it now a little bit over-engineered system, the question is the ecosystem already ready to catch up? So again, what we can learn from Ethernet, that's not from us, for me, it's from Robert McCarthy, about the Ethernet business model. It begins with the de jure standard. If you see ugly, horrible, but wonderful competition. I think it's pretty what we feel today, okay? Evolution of standard-based and how going things are shipped, clear. Maximize the backward compatibility, and an ethic and competitive marketplace is very, very important. Where it's not allowed to be incompatible. Very, very important. That's something that we sometimes forget, and I think it's really good that we're working together as friends. Maybe competitions, yes, that's okay. But in the end, we are one family. Yeah? And working together and be clear that the ecosystem we are building up is our future. It's really important that we take care, that we try to prevent incompatibility as good as possible. Huh? So what can we learn from the 50 years success story of Ethernet? Use real standards and not proprietary solutions to build a competitive market, yeah? And try to maximize the backward compatibility. And customers must not allow incompatibility in the ecosystem. The customer is very important in the ecosystem, and the customer should not be only consumers. If the customer is only consumer, it is the end of the line. So that's the message to all of the OEMs here in the field. Please be careful and try to help us try to drive this thing here. Huh? So what we have to do, again, maximize the interoperability. Standards are king. I said a lot of things about standardization already. I think that that's very important. and OEMs are not just customers. They have to work with us together on the ecosystem. And it is even important that sometimes it's really the situation that a lot of people say the future is circular. Sometimes we really see that a lot of solutions are reinvented again and again and again. That's why it's important to work with strategic partnerships to create better solutions, to have this ecosystem up and running, and don't think you can develop everything at zero because the complexity is getting too high. So now in a summary, I'm still in front of the time, I would say. As a summary, the vision turned out quite well, yeah? Until we ran in some troubles with Gigabit, but I told you we solved it already together in the ecosystem. We solved it together as an industry, as the marketplace, the competitive marketplace. That's very good because this will not be there if we would not be that strong. So the whole ecosystem, and I call it now again the Automotive Ethernet family, works together and always find good solutions in the end. Yeah? It is not too late to improve. And conformance and interoperability testing are essential. If you think you can save money there, you make the big mistake for the future. The money you have to invest there is really, really good investment. It looks like simple, but it isn't, because we see that everybody thinks the other is doing it, and then nobody's doing it. That's very, very dangerous. And that's why I said, okay, this is one of the big things that should be done, and it's not too late to improve. And especially if we bring a lot of new standards up, we have to catch up there. I see a lot of standards coming up, but my feeling is that this is an issue that is a little bit underestimated. Then try to replace the proprietary solutions. It's clear because if it's not needed, it's always better to go to this, let's say, standard-based ones. And please respect the complexity. I'm pretty sure that complexity is the killer of the future. Complexity where it's not needed is the killer of the future here. Be absolutely careful and try to use complexity where you need, and do not introduce complexity where it's not needed, because the complexity will automatically high. We all in the family, especially the OEMs, must cultivate this ecosystem, I'm pretty sure. And strategic alliances are important to reduce proprietary mistakes. So it's really important. It's not always the situation there's a customer, a supplier. In the end, we are working together in one ecosystem, and we really should find the right way to find the right win-win situations. In the next year, handling and limiting the complexity, from my point of view, will be the top priority. Standardization will stay important as it is today. Higher speeds are coming up. More quality of service requirements will come up. More things to deal with mixing of speed grades, being careful of having overflow of any links. This will be parts of the system. And what we learned in the past, starting with a reference design is really, really good. If you always start at zero and you do not use the lessons learned out of the next years, you always come to a certain point, and then you do not solve the last percent, 10% that you need for a good start of production or a stable run. So the good news is the vision that Robert McCarthy, or the postulations that he had, is still true. It's right there. We have still a lot of things to do, and we should not stop our activity to drive the standard. And all of us sitting in the room should not be only the consumer. Everybody, and that is a wish from my point of view, if you try to work with us, working the system again, we will have maybe a very interesting future. Thank you.